Before we get into Newton's laws of motion, let's look at some basic operations of vectors. And one of those is vector addition. So if we add two vectors A and B, one way to visualize this is to put the tail of the two vectors together and draw a line parallel to vector A and another line parallel to vector B. And these form a parallelogram, and the resultant vector C is drawn between the opposite points of that parallelogram. Now another way we can add these vectors is the head to tail method. So we put the head of vector A on the tail of vector B, and then draw the resultant vector from the tail of vector A to the head of vector B. And similarly, we can add B to A by placing the tail of vector A on the head of vector B, and the resultant vector C is drawn from the tail of vector B to the head of vector A. And we can see that the resultant vector C has the same magnitude and direction. So therefore, vector addition is commutative, meaning it doesn't matter which order we add these vectors. Another basic operation on vectors is scaling. So if we multiply a scalar or a number by a vector, then we effectively shorten or lengthen that vector. And assuming s is greater than 0, then we either shorten or lengthen that vector. So for example, if we take the horizontal and vertical components of A, as we've done previously in projectile motion, so we'll write the vector in terms of the sum of the horizontal component and the vertical component. And if you multiply this by a number, then we're basically scaling those two components. So if s is between 0 and 1, then we reduce the length of that vector, and if s is greater than 1, then we increase the length of the vector. And if s is equal to 1, well, as we can see, the vector is unchanged. Now for a special case where s is equal to minus 1, then basically we're negating the x and y components. And you get the idea for the special case where s is between minus 1 and 0, and s is less than minus 1. So have a think about those cases. Another basic vector operation is subtraction. So here we have vector A minus B, which is the same thing as negating B by multiplying B by negative 1 and adding this to A. So therefore, using the head to tail method, we can put the tail of vector B on the head of vector A as shown, and draw the resultant vector from the tail of vector A to the head of vector B. Now in contrast, if we subtracted A from B, which is the same thing as negating A and adding that to B, well, as we can see, the resultant vector in this case, which is drawn from the tail of B to the head of minus A, is not the same vector that we obtained when we did this operation in reverse. So therefore, vector subtraction is not commutative, and the order of vectors in the subtraction matters.